Integration testing is all about testing how well the different parts of your code work together. Work as in, I know, testing the scenarios are better said than done because it is difficult. It is not easy to simulate the environment for integration testing. Setting up databases with data as real as possible, simulating dependencies such as message queues, servers, or even UI tests. So, what do we do when things are difficult? Either we drop that part, problem solve, or barely do them. So if you are either of these categories, I'd recommend you try out test containers, which help you simulate your testing environment and test the code without all the pain. But when you start with test containers, there's high chances that you have more questions that you will seek answers to, like how to debug your container building complex server topologies. If you're looking to solutions to similar questions, more, this session is for you. Hi everyone, thanks for joining in for another IntelliJ Idea live stream. I'm your host, Mala Gupta. And now let me add our amazing speaker to the stream. Hi Oleg, it's a pleasure to have you present with us today.
Hi, it's a pleasure to be here. Honored to be invited.
Now let me introduce Oleg, a fellow Java champion. Oleg also works as a developer advocate with creator of Testcontainers, and he also co-leads the virtual JAG. So, Oleg, before we start with the session, and I let you take the floor, what is your favorite feature from Testcontainers?
Favorite feature of Testcontainers? That's a good question. Let me answer it with the question as well. What is your favorite programming language, Mala? Because we have libraries for Testcontainers in different ones, like .NET, Golang.
Let me guess, .NET? No, Java, because we are in a Java live stream.
Yes, absolutely. We love all the languages, to be honest, and both in the Testcontainers community and at Atomic Jar. But I'm very happy that you said Java because my background is mostly from the Java ecosystem. So I would be way less confident in talking about Testcontainers for Go, besides like the sort of the high level basics and examples. I think for the Java version, I have two. The absolutely key thing is the ecosystem of modules, which have different technologies sort of pre-packaged for you to run with test containers. Right. And if we are talking about a particular technology, I think that would be the ToxiProxy module. And I'm going to show a little example, but in short, you can build complex topologies of the containers that you want to run with your tests. And then you can use ToxiProxy to kind of sort of proxy and introduce various network effects to do like case engineering things. So like cutting connection to the database in the middle of the test and like checking whether your application survives that or not, or introducing latency. Like that's a very fun type of testing, and I think that is my absolute favorite.
That makes a lot of sense, and I'm glad you mentioned Java because what else could we expect from a Java champion, right?
I don't know.
Right.
I don't know. but it's
Okay,
Java is my bread and butter, so this is good.
Me too. Right. And I know that we are talking about the advanced features of test containers in this session. So anyone who is watching this session and they want to get started with test containers, is there any session of yours or any other resource that you would like them to refer to?
Well, in the session, we're going to go through a little bit of basics as well, very quickly.
Okay.
We're gonna. So I think even if you are not particularly experienced with test containers, you can get up to speed here very, very, very much and very well. And it's just a matter of I don't know, trying it out on your projects. That's how you learn the best. Yeah. But I'll also we can see other conferences, live streams, and maybe resources. I can think about it and then give you the links.
That makes sense. I just wanted to address this question because I would assume that a lot of viewers now might not have any experience working with test containers, and it could be kind of a showstopper for them to kind of jump on to the advanced features without knowing the basics. So thank you so much for answering that part. And before I let you take the floor, let me share some quick housekeeping details. Everyone who's watching, please use the YouTube chat to post your questions. Oleg will take breaks while presenting so that he can answer the questions, and we'll also try to answer your questions from the JetBrains team. The session is being recorded and will be hosted on IntelliJ Idea's YouTube channel. So if you haven't already subscribed to our channel, now is the time to do so. And if you like today's session, which I'm sure you would, please like the video and subscribe to the channel. Did I repeat that? Okay. Oleg, the floor is all yours, and I'll be backstage. And where is your stream? Yes, it's already here. So
Okay.
have fun.
Thank you very much. Thank you very much. We're gonna try to have fun. Just if the stream disconnects and it happens that I'm just sitting here in my room yelling at the computer for no reason, then please tell me, interrupt me, because I might miss that moment. But that will not happen. It's all well tested. We all know that if it works in the test, it will work in production, and so on. Right, we're going to talk about test containers. And I work as the developer advocate at the company called IntelliJ, which was created by the maintainers of the test containers Java last year. And we try to support, well, we not try, we do support the test containers community to the best of our ability. And if you have questions and you're watching this in the recording and you don't get to ask them live here in the chat, just reach out to me online. I feel like I'm old and wise now. Recently became old and wise, and I can give advice. I can give advice, but not just about test containers, but in general, testing, software development. I'd love to chat with you about what you think. So let's talk about tests, though. Tests are essentially in software engineering, in our day-to-day life. Tests are sort of the answer to everything. And you might not believe this, or you might be not fully appreciate this, but it truly is, right? All the normal software development question: am I making progress towards creating a feature? Do you have tests? Are the tests passing more than they were passing last hour? Good. Like when you develop something, like, are you breaking somebody else's code, right? Can you merge things? Well, run the tests. Like, do tests pass? Then you're good. If tests fail, then probably you shouldn't be merging things, right? So it's just literally the only question that matters. And of course, that's not 100% true, but a lot of questions actually are answered by having tests and running them. Because sort of even if you don't do the DevOps methodology, right? If you just sort of work in the like smaller teams where they have the operations separate from the development, or you're working on things like libraries where there's not so much monitoring and operating, but like you just throw the jar into the Maven Central, something like this. Still, tests are on the critical path from typing in the code to actually giving that code to your users, right? And you cannot avoid that. So if any of the phases becomes a bottleneck, then you are struggling and your whole cycle is becoming slower, and that is very, very often not desirable. So tests are very important, and hopefully everyone agrees. So in the past, what we did, we imagined that there are different types of tests, and we would like sort of cover most of our code with unit tests, and then we'll be integration tests on top of that. And unit tests will run everything in isolation, as small units of code as possible. And then they will be quick, they will be fast. We're going to cover all our logic with them. And then integration tests will be slower and harder to maintain, and we'll have less of them. And then end-to-end tests, which run in an environment similar to like production, they will be like even fewer of those. And for a long time, this like paradigm sort of worked. But in the recent years, specifically with the migration towards small applications, microservices, and so on, we started, and we as a community here, different teams started to rethink how they do testing. And there are a number of articles how people kind of organize their testing, but the main concept sort of is that integration tests are rising in popularity and importance, because the smaller your application is, the more it depends on its environment and how it runs against the different technologies, like maybe cloud technologies or databases, or it always needs like a message broker for working. So integration tests that can run in the environment similar to production become more and more important, because maybe your application just passes the data back and forth, which a lot of microservices do, and then there is not so much to test with unit tests. So those higher level, more sort of functional tests become more and more important. And you still have the unit test, implementation detail tests, and you still have the integrated tests which run in the environment similar to production, sort of like staging environment maybe, or like a canary deployment if you actually test in production. But the bulk of the decision whether the code that you have is good to be rolled out or not lies on the integration test suite. And that's where Testcontainers comes in. Testcontainers is a collection of libraries in different languages to that integrate with Docker environments and allow you to run various technologies like databases, message brokers, headless browsers, anything that runs in Docker. It allows you to run in a Docker container. And on the other end, you can use that. Testcontainers gives you the programmatic API to manage the lifecycle and configuration of those services. So what you can do, you can make your tests, create the environment for the integration testing that the tests require. And because you have the flexible programmatic API, you as a developer hold the key to the success of those tests. Right? You don't need to ask your platform team to kind of provision you instances of the services. You don't need to install it locally on your machine. You can have your tests consistently across all the environments where you run tests, which means all your colleagues, anyone who clones a project, your CI servers. Testcontainers has been and has seen an incredible growth lately. Earlier this year, the technology radar by ThoughtWorks put Testcontainers into the adopt category, saying that, oh, this is a great default option, and implying that you should have sort of you should understand what you're doing and have a good reason to not use Testcontainers for your project, which is very, very good. How does it work? Testcontainers requires a Docker environment this is where we actually run the containers. And that could be any Docker environment, compatible API environment. So it could be Docker desktop that you run locally. It could be a Docker machine, which is how we previously ran Docker on Mac OS and Windows, which is a deprecated project now, but it still works. It could be your favorite Kubernetes cluster exposing Docker API, or it could be any compatible Docker API environment. So at Atomic Jar, we are building the cloud backend for running containers during Testcontainers tests, which is called Testcontainers, and you can just come and join on the testcontainers.cloud. You can look at the benefits and so on. I won't go very deeply into the details, but yeah, you can lean on the cloud to run the containers and so on. Docker is great. Why do we do Docker? Why don't we, for example, do something else? Is because we rely on it to isolate the processes and run all the software that we want in any local system, right? Or in any environment where we need to run tests. So you can do the process isolation. You can specify the configuration for the file system, or which, I don't know, if your container runs a database, you can specify what schema you want. You can put memory limits and everything. And it's a very good platform, which is just like Java. It is sort of available everywhere. It is available with the consistent user experience on all necessary platforms. And what it's more important, almost all software that you run can be run in Docker, right? Like you have the images to run all the databases, all the message brokers, your Kafka, your HiveMQ, your Kubernetes clusters, your I don't know, everything, MongoDB or any Redis or anything. You can also run your services, right? If you have your internal services that your tests depend on, you can also run them in Docker because you can package them into images and run the containers out of those. But Docker API using the command line directly or using the configuration options that Docker provides out of the box is a little bit clunky. Specifically for the integration tests, because during the tests we want to put our application and environment into the sort of edge cases, right? That's what the tests are for, right? We want to check what will happen when the database schema is this way, or when your Kafka topic has those messages. Like, do we process that information correctly or not? And for that, sometimes we need more flexibility in configuration that the kind of sort of out of the box non API Docker integrations can provide, right? So Testcontainers does a few things. It gives you the API to do the container lifecycle and cleanup, to container both container and service configuration, and it gives you integration with frameworks or your test libraries. And if we talk about specifically Testcontainers for Java, then it's a mature project. It's very, very old. It's not like that old in Java years, right? So what is Java? 27 now? 27? Coming 27, which is ridiculously old. I feel I feel like it's almost as old as me. But it's in the Docker years, Testcontainers Java is very, very mature. Docker is barely older than the project itself. And of course, Testcontainers libraries are open source projects. They sit on GitHub under the Testcontainers organization, and they use Docker API, so they don't rely on the particular command line tooling, and then they integrate with the frameworks in the respective ecosystems and languages. So for Java, that is integration with JUnit, or Spock integration with Spring and Quarkus and Micronaut and so on. So you can use it. You can use it without those tools. You can use the API directly, but there is also integrations, right? And there is the whole library of which I mentioned in the beginning, right? There is a library. There is an ecosystem of libraries where the configuration for the particular technologies is already created for you, so you don't have to fully understand how to run, like, subtle details of how to run Kafka in a Docker container, or how to run your Kubernetes in a Docker container, or whether that is even possible, or what exactly needs to be done. You can just use your programmatic API, add a dependency into your project, and click the dot and the alt enter in your IDE, and then go, right? It will write the code for you. I haven't tried. Maybe maybe you can even ask the AI to write things for you, and it will respond meaningful. No, personally, I would not recommend that. If I would choose, oh, this is an interesting question, and it's completely off topic, but I feel it's very, very modern and very interesting. So 20 seconds of attention. If I would choose which part of the code to generate, whether to generate the code and write the test myself, or write the code and generate the tests, I would choose to write the tests myself, because they verify. I need to be certain that the things we're writing or generating, they actually do the thing that I want to do, right? Writing the code and generating the test sounds like a counterproductive measure, but this is, I don't know. I haven't thought about this for enough time for this to be like an important takeaway. This is just yeah, the alt enter comment made me think about that. Right. So sorry about that. The module of the ecosystem of modules, which is great. And the other thing is, as I mentioned earlier, Testcontainers is not just a Java library. There are other implementations in the popular programming languages. So like things like JVM languages like Kotlin, for example, can easily use Testcontainers Java because there is a native interoperability between those. But for the other languages like Golang or .NET languages or Rust, there is Testcontainers Python. So you can use the same approaches of integrating with the Docker environments and creating environment for your tests, ephemeral environments for your tests on the fly. They are available in your favorite languages, and they're all open source projects. So if you use particular language, just go, or you have friends. I know this is Java oriented stream, so if you have friends or colleagues who are using another language, there is Testcontainers.net for your JavaScript and TypeScript developers. So you can go to them and say like, oh, look, this is a great library in Java. We're using it all the time. And I just learned from Oleg that there is Testcontainers Go. Maybe you should go check it out. And they will be like, oh my God, this is the best early winter's holiday present ever. And they will be grateful, and they will bring you beverages and things. Right. So this is sort of the introduction, very quick introduction. I'm going to go now into my IDE, and we're going to try and see what the tests are and how they work, and what are the common patterns, and what are some features that you might not have heard of, and how to use that effectively, right? Do I have any questions in the chat? I have a bunch of comments, but okay. But if we have questions right now, I think this is a good idea to ask them. Mala?
Oleg, we do have a couple of questions, but they are more, as you said, they're more like comments. Just one question. Okay, so there's a question by Yuri. You can see that on your screen now. Taking to account a Docker license doesn't allow to use it in any companies. Is there any choice to use test containers without Docker? So the question is probably about the alternates. Would you like to address this question now, or
Yeah,
if you're all
yes. Of course I can. So Testcontainers requires you to have a Docker compatible API available somewhere. So that means that you can use any Docker implementation. And I think the question refers to the changes to the Docker desktop licensing that came earlier this year, I think in January, which feels like an eternity ago, unfortunately. But it doesn't have to be your Docker desktop client. For example, it could be Testcontainers Cloud, or it could be your any Docker implementation available. Or if you're running it on Linux or in your CI, then you can run the same tests and using the Docker daemon directly, which is an open source thing, which doesn't include you don't need the license, the paid license for that. Or you can use Docker from Minikube, or you can use Kolima or Rancher desktop. There are a number of opportunities, a number of projects which provide you with the Docker compatible environment. So we just need the API because we want to have the direct control and saying like imperatively say, create this network, run this container, pull that image, configure this with those files like that. So a very imperative approach to giving commands to this API, or cleaning up the containers, which is a big thing. We want to be able to say like all the containers that were started from this session, please remove those. And this is something that uses Docker API. So I don't think other targets are, well, in the active development at least. So yeah, but there are a number of options. Right.
That was a long list. So the others are more of comments. So I'll let you move forward with your session.
Yes, thank you very much. So what I have here is a very simple application. It's a Spring application. It consists of a controller, and the business logic of this application is fairly trivial. It takes in HTTP requests, and then it sort of deals with assigning ratings to sessions at conferences. But for our purposes, what's important is that it uses Kafka via the Kafka template, and the ratings repository here will use Redis templates. So it means that we'll need to have Redis to run this. And the talks repository will talk to our normal relational database using the JDBC template. So we need those three things to run this application, and that environment needs to be there. So what else I have? I have, oh, Mala will be like, you are doing a little too much clicking. Sorry, it's just, for the demos, I usually do this. Let's remove that. And what I have here is in the test directory, I have a collection of tests. There are some that are fairly straightforward. It's just the context load test, which checks whether my application wires it together, and that the data exists in the sample database. There is the check that our actuator for Spring application actually uses and returns 200. And we're using the rest assured library, which is very, very cool. And it gives us the Fluent API to create HTTP requests. So those requests that go through the HTTP, they are doing actual request generation, and they actually send the HTTP request there. So we do that. There is the test ratings check, which actually sends the data to the application and awaits until it comes out from the other side. So that technically through the application, business logic means that it does the whole round trip into the database, out of the database, into Kafka, to Redis, everything, and then you respond back. We will use awaitility, which is another great library for dealing with any asynchronous events. We use that internally in Testcontainers Java quite a bit for waiting for various things. Like, for example, when you start the container, and in the container you start some service, say you start the database, or you start your IntelliJ IDEA backend, and then you need to wait for it to become ready, right? So database to accept, get to the point where it can accept the queries, or where the indexes are downloaded and applied for your IDE. You need to wait for that and only then return the control to the tests. So there is this asynchronicity that you need to work with, and awaitility is a great library for the tests, and we use that internally to wait for like container started events and so on. So we do the checks for the tests. We also test that there is the negative use cases, which very often people sort of forget in their test suits, or not only test happy pass, but we're better than that in our sample project here, and we test the negative workflows as well. So this is a demo project. Of course, I can run those tests. They will fail currently because there is no environment that I can run. If I wait, I don't want to look there. Where do I want to look? If I go into my terminal, right, and if I do docker ps, it gives me, I think it should tell me that my docker is down. Yes. Right, we'll see. Right. This is getting intense. Right, there are no containers running. We're gonna create that environment for ourselves. We're gonna use this abstract integration test class here. We're gonna specify the containers that we want, and we're gonna do three things, right? We need the lifecycle control, the configuration of the services, and the sort of integration back into the application. So we cannot just run the database or something. We need to make sure that our application knows where the database is located. So how do you start with test containers? This is very simple, and this is for people who are not experienced, is that you just add a bunch of dependencies, right? You add you can add in all the modules that you want. So we have Kafka, test containers, Postgres, Mongo, and I think all the rest as well, right? A bunch of them, and we add the integration with JUnit, which will pull in the core as well. So let's go back to the test, and what we can do, we can start writing the things. So for example, we can do new generic container, and we can do wait, generic container. And what we need to give it, we need to give the Docker image name and tag. We're going to start with Redis. We're going to start with Redis, and we're going to do the field. We're going to do the static field here, generic container, and then we do Redis equals new generic container. Very good. Right. And so here we can give the tag for and the Docker image name and the tag for what we want. We're going to pull Redis 6 Alpine. This image, of course, if we don't have it locally, it will be pulled from the Docker Hub, right? So this is the official Redis image that we're going to be using in our application. And what we're going to do, so now this is the container, right? So this is the object that we can work with. So we can say anything that we want. We can start or stop the container. So we have the lifecycle configuration methods. What we can do also, we can do all kinds of configuration. We can specify the environment. We can specify what ports need to be exposed from the container to the host, what network it belongs, commands, and so on. We can override the Docker image commands if we want to have a specific ones. We can copy files to the container or after the lifecycle out of the container. We can execute commands in the container when they're started. So anything that you can do with the Docker container, you get the API here to do that from your favorite programming language, which is great because you can just, that's what I said. Like, oh, this is my probably even better feature that I love, right? It just, I can type dot and I can see exactly what I want to do, what I can do, which is absolutely incredible. So we're not going to do this. What we're going to do, we're going to say we want to expose the port. Redis will be accessed through the network. So 6379 is the port which Redis uses internally. So this is the internal port within the container, and it will be mapped to a high-level random port on my host machine, which is absolutely incredible. And this is it, right? So now what I need to do, this is my configuration, and my test declares that it needs Redis to work, right? If my test runs with Docker, boom, done. My application is there, and I can use it to run any Docker image possible, right? I can pull it from private registries, like internal registries in my VPN. If it's my local things, I can do anything, and I have an API to do that. So I showed you the lifecycle methods, and then there are a bunch of things that you can do, right? So one thing is you can use the JUnit integration. So you can mark the Testcontainers annotation on the class, and you can mark all the startables with the container annotation like this. And those two guys, those two friends will what they will do, they will tie the lifecycle of the controller, of that container, to the lifecycle of your unit tests. Those are JUnit 5 annotations, and they will literally start and stop the container for you. So if it is a static field, they will act as a sort of before all and after all. So they will start the containers once per all the tests method in the class. And if this is an instance field like this, they will start the new container for every test method in your class. I see a question from Ani about how to start the Redis cluster. This is a good question. You can do. I don't have an exact configuration here, but what's cool about this situation? Let me remove those. If I want to do like a bunch of Redises, I can do that. There are no conflicts with the ports or anything because the configuration for the exposing things are the configuration is dynamic. So I can start 2 of those and then put them on the same network. So like, I can do static network, network equals new network, right? And then I can configure them with network, right? And then surprisingly, with network, they will be on the same network. And then given enough prowess with the configuring Redis, I can just bunch them in a cluster. I hope that answers the question. I'm sorry. I looked at the chat. I saw that one question. I responded to that. But we don't need two Redises here. So what we can do, we can just say like, oh, we do one Redis here. Now we need to start it, and we need to like put the information into our Spring application. What we're going to do, we're going to create the method annotated with dynamic property source. This is the Spring facility. So this is the Spring solution, but essentially it shows what you need to do. Wait, I need a static method, right? Void setup things, and then I will give it the dynamic property registry, and then this registry, this method marked with dynamic property source, will be executed before my test start. And whatever I can do with this registry, I can put data in it, I can put properties in it, and then it will be used to overwrite whatever static configuration I have. So I can do Spring Redis host, and then put the host here. And the host for my Redis container is, of course, I don't know where it's running. So the easiest is to get host. Right? Because my container here, right, my object knows where I have it. So, and then the same with port, right? I can do. I don't know what port I need to have, because this is randomly dynamically generated at runtime, but I can do the get first map port. So we map port 6379 internally into a random port, and we can just ask it from here. That's what the dynamic API gives me. It just runs this. So this is the configuration. This is how we tie it into the Spring, and then we just need to start it. So we're going to say Redis start, and then, oh wait, just join the thing, right? So this is just the utility method from Testcontainers that starts multiple containers. It can start multiple containers in parallel, or the chains of containers if I have, like, depend on other containers being started, and then it can build like complex hierarchies of things. So this will give me the Redis in 1, 2, 3, 4, 5, 6, 7, 7 lines, 5 lines actually, if I don't do the formatting nicely, which you should. Everyone should format their code nicely. Otherwise, you are not doing everything you can to make other people's life easier. So we have Redis. And as you can see, even if you have internal things that for which you don't have the Testcontainers module, you can do the configuration very, very easily. Your IDE supports it, and it all works with just the API. And here we will take care of the lifecycle ourselves. So we are not tying the lifecycle of this Redis to the lifecycle of unit tests. Because for our test suite, we don't need that kind of isolation that parts of the test use one configuration, parts of the test use another configuration. We can just be like fairly, we have a small test suite here. So we are not going to start the containers again and again. We're going to just start them once. And we're not going to even care about stopping them. Testcontainers features a resource reaper mechanism. We use a Docker image called the Rook, which actually, like, I think yesterday, just passed the 100 million pulls on Docker Hub, which is 100 million is pretty sweet, I think. So, and that Docker container that will start, it will record all the tests, all the containers that we run from the test session. And then even if your test crash, and even if your JVM process like just disappears with a seg fault or something, or if you're running with the remote Docker and your machine crashes, there is no internet, after a period of inactivity, it will just clean up everything. That ensures not just that the resources are freed, but it also ensures that there are no lingering things in your system. That means that you can run tests again and again and then again and again, and then it will run. James has a question. If you have 5 integration test classes and you use before test and after test, one that starts top the container 5 different times. That is an interesting question. It depends, like if you use before all and after all, or before each and after each, and then it will start and stop the containers. If you use the annotations, it will start to store the containers according to those before each or before all rules. I'm not sure JUnit at least exposes annotations for, maybe, are you even talking about JUnit? Maybe not. Hopefully. Uh, this is the JUnit 4 maybe, or even something else. Anyway, what I wanted to say is you have the full control. You can manually control when you start the containers, and you can build any complex hierarchies of when to start and stop them. Right, so we have Redis. Let's do Kafka. Kafka is even easier because I can do Kafka container because I have my Kafka dependency, and I can just say Kafka container equals new Kafka container, and then I just need the Docker image name. So you can also have the full Docker image name parse functionality if you want to parse the images yourself with the more complicated strategies. So let's do the content inc. This is the default one, right? CP Kafka, and then 5, 4, 6, right? I think this is the version that exists there. Let me double check. Yeah, Kafka, CP Kafka, yes, very, very good. This is very cool. I know this. I cannot take credit for this, but this is IDEA doing the work, right? There is a content assist. There is a content assist on strings within Testcontainers API, and I think some other context where Docker image names strings are auto-completed, which is a recent feature. And kudos, this this makes my life demoing so much better because very often those are strings, right? Nobody likes strings because that's where you make typos. And then this is just brilliant. You can also pull things there if you want, just from the context action, right? So we do Kafka, and we don't even need to configure anything because everything there is pre-configured already, which is sweet, right? So we need to start our Kafka, right? And then we just need to configure Kafka. So this is Spring Kafka, and it's called Bootstrap Servers. I know this because this is the configuration property. What it looks like, I don't know, but I can just use the API here. Did you see that? Get Bootstrap Servers. I don't even need to know how to configure things. I can just rely on somebody understanding how to do that for me. Right, so we did Kafka now, and this is very, very simple. We started, we did everything, and then let's do the database. So let's do very quickly database, static Postgres container. Here's the thing, I'm going to show you the website. I'm not going to type it in, but I'm going to show you the website. So testcontainers.com or testcontainers work, which is for Java, and then there's a called JDBC thing. The JDBC support. I could type it in, but I don't want to. I'm going to show it for you. So for the JDBC URLs, for the JDBC databases using JDBC, like Postgres or MySQL and whatnot, what we can do, we can have there is a special driver that you can use. You can take the normal JDBC URL and you can insert the TC prefix in there, suffix, middle part into the thing, and then the control will begin to the JDBC test container driver, and it will create the database based on the Docker image name and the tag that you provide, and it will wire it back into your application. So you can just specify this one property, like sort of like this. But I will not just run it but like somewhere, I don't know, here, right? So you can do Spring data source URL like that. It's both of me to say that I'm not going to do this and then do it. But like this is enough to create a database. This is not the most flexible method, but this is the easiest if you just want to sprinkle test containers into your application. But we're going to do this like manually. So I'm going to do Postgres, and I'm going to do Postgres container, and I'm going to say new Postgres container. And this is, I think, Postgres 14 Alpine. Yes, 14 Alpine. I don't need to do any other configuration because it will be created with some default database name and username name and other things. And it will also specify what to expose, and it will specify what does it mean for the container to be ready. This is what we said before about talking about asynchronity of starting things. But what I just need to do, I just need to configure that Postgres, and then I can do the same things, right? We just need to registry, add string data source URL, and then we do Postgres get JDBC URL, right? And this is just perfect. Get username, and then get password, and then here we say username and password. Right, so I think this is it. We start the containers, we run the things, and we configure the things. And now I think if I run those tests, I think they should work. Do you think they work? Okay, so let's see what happened. Well, let's see what happened in our logs here when we run this. The test containers found the Docker environment and connected to the Docker environment, and then because it's a clean cloud VM, it will pull the images for me once, and then if the images are in the local cache, they will be of course using the local cache, and then will not pull the images again and again and again, and then it will start those containers that we wanted. So if we do here, for example, if we find here started, so for example, some container Rook, this is the resource reaper, with a very aptly named Docker image name, starts very fast, and then the rest we need to pull, so they will start a little bit slower. But if we rerun the tests, and then very quickly you will see that containers start actually very, very fast. So Postgres starts in like 3 seconds. Kafka starts in less than 10. So if you run them for your integration tests, then you can run the test very, very quickly. The test rating checks the whole suite of your application here, so that's why it takes a few seconds to run, because it's the longest test, but it runs and it works. So now what I can do now a few things. That the typical question. Do you have any questions here?
Here, Shiva is answering a lot of questions. So there's one question from Anil, which I wanted to ask. He posted that question initially, and he said, will you cover the Podman setup just like Docker? Because a lot of companies use Podman. So would you include that in your demo?
Podman, I will not include in my demo. Podman,
Okay.
I know that's a great question. That is a very interesting question. Podman project is, I think it tries to be like a Docker compatible substitute that goes from a little bit different security and the usage practices. And it's an open source project. And I know that there are some recipes where people made test containers tests work with Podman well. Last time we tried to run test containers Java test suite with Podman. Unfortunately, it broke, and there were some incompatibilities. Right, so Podman might be very compatible on the command line level, for example. I'm not sure. I will not claim, and I don't want to claim where it is or not. But since they position as a substitute for Docker, I assume that they are. But for test containers, goes and talks directly through the API, which is a more powerful kind of sort of surface, right? And then some things are there that might be missing or might behave in a different way. And we are working with the Podman team. Both projects are open source, test containers and Podman. And I just know that there are some issues that you can stumble upon, right? Whether you will or whether you will like figure out a configuration where your particular tests work with Podman, you might very well figure it out. And I know people who did, but I would not claim that it is like a sort of an out of the box solution. Yeah, So, for example, if you're asking, I think trying Minikube, which is local Kubernetes installation that exposes Docker API, right? I think with that one, you would have easier time out of the box on your local development machine. Yeah. Or I don't know, Testcontainers Cloud. Sorry. No,
And,
it yeah. So Podman is interesting, and I hope this will all work out. But and then it will be compatible. But there is currently no Podman specific code in Testcontainers projects because we work with any compatible Docker API, right? So and there are some issues that are open on GitHub. So
so Shiva is already asking a lot of questions. One quick question: do you already have this code up on your GitHub account so that anyone who's watching can follow along, or would you post that after the session?
No, the code is there. I have a link to that later, but like if you go to the Testcontainers slash I think workshop. So this
Okay.
is actually like the whole workshop in which you can create this application that I'm running.
Okay. Okay.
And then if you
That's right.
go to say Shalive, and I think it's called Testcontainers Red Panda, which is a
Okay.
it's a repository that I used for a different piece of content, a blog post about running Red Panda, which is sort of Kafka implementation running tests. And this one is sort of like a cheat code for the workshop because it contains the application in its close to final form. So if you go to that repository, you can just run it, and this is the final version, which is I think very close to what we currently have here. Instead of
Okay.
using Red Panda container instead of the Kafka in the Confluence Kafka, right?
Okay.
So
I'll let you move forward with your session because we are kind of running out of time, and
yes,
I'll ask the rest of the questions later then.
right. So we're running a little bit out of time. So what I want to show, what I could show you as well, right, is how to configure things for our database, right? So currently, I think application properties specify that our Spring application initializes the database. So this is never usually what you do in production. So this is not something that you would do in your tests as well, right? So in production, you would probably have the database migration story with Flyway or Liquidbase, and you probably should have the same setup in your integration test to check both that the migrations are fine and then to check that well, your infrastructure supports that and it runs normally. So I will not run the migrations, but I will show you a even more maybe generic way of doing things. So what I can do here with my database container, I can copy files to the container, and I will just do from the class path resource file, which is the schema SQL, right? Yeah, it's a schema SQL, which is the schema that is for my tests, and I need to put it in a directory in my Postgres container for the Postgres to digest it in. So scripts, initialization scripts. Most containers have most images have some sort of configuration like this. So it's not just database specific. Usually it's like if you have like, I don't know, like a conc ingress Docker container that you want to run, you will put a configuration file in there in a specific location. It will pick it up during startup and it will run those. So for databases, this is one of the most convenient ways to initialize the database. You can just put the whole schema into this predefined location. So we're going to do this just like that, right? And then that will mean that during the container creation, this file will be copied in that, and then Postgres would initialize the database by itself. So if, for example, I run just once this simple test, I don't want to run all of them, even without Spring initializing the data, it will pass because now Postgres will initialize the data for me. And this is how you can configure all the technologies, right? What? Wait. Oh my God, was not supposed to happen. Let's see. Couldn't create start container. What? Is it right? Schema SQL. Create table, context, nothing. Why? Let me run this. Right, we create the container and we copy. Oh, copy file to the container. Sorry. Right, so now it should run. Right, anyway. Right, this is how you can configure all or anything that runs in the container. This is how you configure your applications, or look, it's green now. Oh, looking at the green tests. Check this out. Check this out. This is one of the rare moments of joy and happiness in any developer's life. Because next you're going to commit the code, you need to clean it up, you need to do a bunch of chores, you need to push it, and then you take the next task, and it also starts with looking at the red tests. So this is nice. If this isn't nice, I don't know what is. Right, so let's remove this. What I want to show, I cannot talk about toxic proxy and not show toxic proxy, right? So very quickly, static toxic proxy container, and this is brilliant. Proxy equals new toxic proxy container, and it goes from Shopify, and then this is toxic proxy 210, I think 210. Now this needs to be put on the same network with network. Is network, and then we're going to experiment on Redis. We're going to say with network alias. I'm not sure actually if this is needed in the that much needed or not. And then we're going to start the toxic proxy, and then we're going to say proxy, get proxy for Redis, and then for port 6379, because that's where the Redis is, what Redis exposing. This is our proxy, and then we're going to do the proxy here. So instead of feeding into Spring the configuration of this, get container IP address, and then proxy get proxy port, right? So now our application will go into proxy, and now our application will go into talk to Redis via the proxy. So let's run this one test ratings test. Just I want to show you very quickly how it runs. And while it runs, because I mostly just want to show you the timing of the block of the test here. What I can do now with toxic proxy, and this is where the fun begins. I can say toxics. Oh no, not the toxic proxy. Toxics. Latency, and then we want say downstream. Every latency downstream is 2 seconds long. So every time we want to downstream from exception. Right. So now we introduce the additional latency, and maybe even we'll set jitter like another 100. Right. So every interaction will be 2 seconds. So now the test that run in under 10 seconds is going to be so much longer. It's going to be incredible. So much longer. Right. We're running almost out of time. The test will run in more than 20 seconds. If I put the latency here 5 seconds, it will actually break, because there is a 5-second default timeout to accessing Redis in the template. So we will, it will just fail because some interactions are longer, which is exactly what case testing can be doing. Look, 20 seconds, twice as long for every interaction. And the best part is about this being all API driven. What you can do as a developer, you can take the configuration for the container, you can take the toxic proxy or any particular Docker configuration, and you can package it in a module of your own. You can create an abstraction for your peers to use at your company, right? And it will use the particular things, right? So it will use the particular setup. You can make everyone do tests with the chaos testing practices, or like with networks cut intermittently here and there. and they will not even know that out of the box. Right. Right. Yeah.
Sorry, were you waiting for me to kind of hop on to the stream? I'm
No, because
sorry.
it's the time. But like what I wanted just to say
Okay.
is that there are like a bunch of things, right? You can do more things, like you can do complex topologies, you can waiting on the fly, you can create images from the Docker files, you can programmatically use build packs, which I have an example, but we don't have time. You can do log files, you can copy the commands, you can set the resource limits to, I don't know, check that your application works with a particular garbage collection that JVM picks by default when there is like not enough memory and whatnot, right? You can also do local development. So modern application frameworks in Java support test containers. Quarkus has dev services. Migrate has test resources. Spring currently has this issue that would like to implement the auto services initiative there, or explore how to use test containers for local development. But in a nutshell, what they do automatically, if your application starts and you don't have the database or your Kafka or your other things configured, you can just, it will start one for you, right? The framework will start one for you. So you don't have to bother with anything. You can just clone the project, run the project, and it will run out of the box as long as you have your Java and a Docker environment available. And then it's just a bunch of URLs. So you can go on the website, you can go check out the actual implementation, contribute fixes and issues and questions, and join the Slack if you would like, because that's where we talk with the community. Right. So that is
Okay,
it.
so I guess, sorry.
Yeah. This is sort of the quick rundown of what I want to show. I like, if we have more time, I can show something else maybe as well. But like, I think we are at the cutoff time.
Yes. So first of all, amazing presentation. I will quickly ask you a few questions because, yes, we're running out of time. So one question is regarding the usage of new 4G test container. One of the viewers, Varun Bharadwaj, he mentioned, of course, he mentioned that he enjoyed the session, and he mentioned that they are using new 4G test container and they are experiencing abrupt shutdown of this container. So is there any known problem with this container? Or probably it's problem with their test code or something else.
Neo4j test container abrupt shutdown. I'm not sure. I don't know. I don't think I've seen any issues in particular.
Mm.
Neo4j developers are good friends and they are good citizens of the open source community. I know that they internally,
Mm.
or like, well, internally, the Neo4j project uses test containers as in the integration test suite. So they are running their integration test for the drivers using test containers. So it might be some sort of your configuration particular issue, or might be something new. But I'm sure it will be, if you raise an issue or a discussion either on the test containers side or for Neo4j, I think maybe easier for in the test containers repositories, then I'm sure this will be resolved pretty quickly.
Okay, so the other question is any pointers or tips about using test containers in CI/CD, because there were a couple of comments about having issues with using test containers or configuring it on using it with CI.
Yes, this is the good question. So most of the issues in CI come from the way that your CI platform runs your tests. Like the test with test containers need access to a Docker environment, so you can. Usually, if your test already run in a container, that means that you either need like a wormhole pattern to allow Docker from the container to access the host, to start containers and kill the containers, or other Docker and Docker setups, or the remote Docker setups. So there might be a little bit of complexity to figure it out for the first time. I think on where's the test containers on the website? On the website, you can
Okay.
see a bunch of various configurations that are maybe some suggestions what particularly do in certain environments. So you can look at those. You can also join the Slack channel, the Slack workspace that you can get in the get help and talk to us and talk to the other people in the community who figure out the similar problems and the configuration for your particular CI platform. And the second thing is sometimes if you start too many containers in a worker that is kind of sort of constrained by the resources, right? If you want to run your tests in a very small container, then running a lot of containers with heavy things might become a resource bottleneck. So for that, you want to have things like maybe a larger workers for your tests, or offload the resources to things like Testcontainers Cloud, where you can, the tests run locally, but the containers run in the cloud. I use Testcontainers Cloud here. Look, check this out. I don't have my Docker running. I run my Testcontainers Cloud, which is a small application user space, sits here in my taskbar, right? And it run all the tests. All the containers were running in the cloud. The tests run locally, and you didn't even notice, which is, I think it's a great testament. So yeah, you can offload some resource to the cloud and then solve the sort of the resource intensiveness of the workers that way. So this is the main problems that I've heard from people about CI.
So one last question I'll take is, what do you already have the roadmap published of test containers on your website?
Oh, this is the good question. I there are better people than me to respond to those. But I think there are in issues there are milestones, right? There are a few milestones which are next is completed, but there is also like a 2.0 milestone which comes with a bunch of improvements that we would like to tackle. If we're talking about test containers Java, other projects, of course, other languages implementations, they have their own particular roadmaps. But I know that there are a number of things that we would like to even just clean up before the bigger, sort of major increase. One of them is test containers exposes JUnit 4 in the public API in one place. In one place, we would love to remove that, but since it is an API breaking change, we cannot do that lightly, and we don't want to do it lightly. So what you need to do for now, or don't need, what you can do, you just can go into your IntelliJ IDEA and make sure that when when you import things, you can just say never import from that package, and you can say never import JUnit for classes, and your IDE will help you, right? And you will never have that problem ever again.
Okay, and I would like to share some amazing comments about the amazing presentation that you had. So we have amazing and very cool presentation. The demo was thrilling. Thank you for the new features. Great work. And there's another one, Sorin, and probably also watched your presentation at DevOps.
Nice. Thank you. Thank you very much.
Great session. And there was one more. Where are they? Great presentation, Oleg, and very informative session. So thank you so much, Oleg. That was an amazing session. Thank you so much for your time today, for presenting with us. I learned a lot.
Thank you very much for having me, and I would be happy to chat with anyone about any questions somewhere online.
And yes, a special thanks to Shiva. He was answering a lot of questions on the chat. So thanks to him.
Yes,
I
Shiva
know
is
that he
amazing.
works with you.
Yes, he recently joined, and he's absolutely spectacular. It's a pleasure to work with him.
Yes, so and everyone who's watching, you can follow Oleg, and the Twitter handle is right here. You can access the code which Oleg demonstrated on his GitHub account as he showed, and of course, um, follow our IntelliJ Idea channel so that you can subscribe and get notified about the new content. I almost forgot that line. So sorry. Thank you so much, everyone, for attending, and we'll see you again next month. Oleg, before we close the stream, if you have any closing comments, you can share that now.
Yes, we're going into the winter holidays thing, so you can take this time to learn maybe some things, and then or recharge, and whatever you do, like stay curious. Hopefully everything is good with you and your closed ones, and yeah, see you out there in the open source community.
Thank you so much. And everyone's watching. We'll see you again next month. And until then, bye bye.